So first of the error coefficient is called the static position error constant, or Kp. So in that case, the equation is written like this. ESS is S into RS upon 1 plus GS into HS, and RS is 1 by S for unit step input. So substitute the value of RS here. So 1 by S into S gets cancelled. So this becomes 1 upon limit S tending to 0, 1 upon GS HS, or limit, this limit can, because 1 is remains the same and this one also remains the same, so this limit shifts from here to here. So it is limit S tending to 0 GS HS, and ESS is basically 1 upon 1 plus Kp, where Kp is called the static position error constant, limit S tending to 0 GS HS. This is the definition of Kp, which is called the static position error constant. Okay. Next is static velocity error constant. Okay, so velocity error constant Kv is defined as ESS limit S into RS into 1 upon 1 plus GSHS. So this system, this remains the same. The only difference is that RS is now unit ramp input. Unit ramp input. So RS is given by 1 upon S square in place of 1 upon S. So it is limit S tending to 0, S into 1 upon S square into 1 upon 1 plus GSHS. So 1 S remains in the denominator. So if you take the limit 1 upon S into S GS HS, and this S can get cancelled, because when we take limit, then this term remains. So limit S tending to 0, 1 upon S GS, and ESS is 1 upon Kv, where Kv is limit S GS HS, where S tending to 0 is the static velocity error coefficient. Similarly, we can define static acceleration error constant. So in that case, the system input is unit parabolic input. So RS is equal to 1 upon S cube. I want you to please write this, substitute the value of 1 upon RS equal to 1 upon S cube, and find out the value of Ka, static acceleration error constant. Okay, so do it yourself and submit on your answer on the Google Classroom in your own handwriting. So if you drive that, you will get certain value. This is the value. 1 upon so for Ka, sorry, Ka is this. Ka is limit s tending to 0 s square ds hs, which is the static acceleration constant, and you get this value by simply substituting rs equal to 1 by sq. Okay, now steady state error for different types of system. Type 0 system with unit step input. So type 0 system is basically one which has no s value in the denominator, that is s equal to 0. So Kp in that case is because it doesn't have a s in the denominator. So Kp is basically defined as limit s tending to 0 GSHS limit s tending to 0. Substitute the value of GSHS, which is k into 1 plus s into t1 into 1 plus s into t2 upon 1 plus sta into 1 plus stb, etc. So if you take the limit, substitute the value of s equal to 0, so that becomes k. So kp is k for type 0 system, and ess is 1 upon 1 plus kp, so it is 1 upon 1 plus k. So steady state error for type 0 system is 1 upon 1 plus k. Okay, type 0 system with unit ramp input. So unit ramp input, kv gives kv, that is velocity error constant. So s into gshs, so s is multiplied with the transfer function. So when you substitute, when you take the limit s tending to 0, this becomes 0. So ess is 1 upon kv. So kv is 0, so it is ess is infinite. All right, so ess becomes infinity for type 0 system, and for type 0 system with unit parabolic input, you can substitute the value of ka. So here it is s square, this becomes 0. So ess is 1 upon ka, which is again infinity. So for type 0 system, the steady state error is infinite for ramp and parabolic input. Hence ramp and parabolic inputs are not acceptable for type 0 system. Now try out the same problem with type 1 system with unit step input, that is m equal to 1. Find out various error constants for type 1 system. Follow the same procedure and find out the response. I am giving you 5 minutes time. So I have uploaded the assignment on Google Classroom. So do it and submit here. All right. So this same way you can find out the error constant for type 1, type 2 systems. Type 3 is becomes a bit more complicated. So we will limit up to type 2 systems. Okay. So let us summarize the result with the help of a table. This table you can draw in your notebook. So this is for type 0 system, units for unit step input, for unit ramp input, and for unit parabolic input. This is basically Kp, Kv, Ka here. So for type 0 systems, we have derived this. Kp is 1 upon, ESS is 1 upon K, and ESS for velocity unit ramp input, K velocity error constant is 0, and Ka is also 0. So ESS becomes infinity. Similarly, for type 1 system, you should get these values, and for type 2 system, you should get these values. So let us do one numerical problem based on the above uh, findings. So let us take a open loop transfer function having unity feedback system. So HS is 1 in this case. So GS is given by 50 upon 1 plus 0.1 S into S plus 10. Determine the steady state error coefficients Kp, Kv, and Ka. This, I want you to solve this problem by following this procedure. Kp is limit GS S tending to 0, GS HS, HS is 1. So basically, you have to just substitute the value of GS here and take the limit S tending to 0. So if you do that, you will get this value, because from this you will get 1, and here you will get 10. So 50 upon 10 becomes 5. So Kp is 5. Similarly, you can find out Kv and Ka. Please find it out yourself and upload your answers on Google Classroom. That again also I am giving you on Google Classroom. Classroom, please solve it and upload the solution in time. All right. Meanwhile, I'll take your attendance. Rule number 1, 10, I will be engaging your class. So be present. Today you took a long time joining the class. Why was that?